first thing you probably think about each morning is a nice hot cup of coffee. It's a great way to wake you up and give you some time to relax before you start your day. But have you ever thought about the mechanisms involved in brewing that hot cup of joe? There's actually quite a lot going on inside that coffee machine. Let's take a look at the different transport mechanisms that take place to turn coffee beans and water into brewed coffee.
There are three main types of transport: heat, mass, and momentum. Heat transport is the transfer of thermal energy and is driven by a temperature gradient. Mass transport is the transfer of molecules via concentration gradient. Momentum transport is the transfer of a fluid that has a density and moves with a certain velocity. Momentum transport is driven by a pressure gradient. All three of these mechanisms can be explored within a coffee machine.
The first mechanism we'll explore is heat transport. There are three types of heat transport mechanisms. Conductive heat transfer is the exchange of heat between molecules that collide or touch. Convective heat transfer is the temperature change induced by fluid motion. This fluid motion can be caused by an external force in forced convection or by density differences in natural or free convection. The last type of heat transport is radiation. This is energy emission in the form of electromagnetic waves. Radiation occurs in all surfaces to some extent. Thus, radiation does take place within a coffee machine, but the two main mechanisms we will explore are conduction and convection. Coffee machines will have a resistive heating element composed of a coiled wire. Electricity runs through the wire, which has a high thermal conductivity, allowing the wire to get hot. Sensors inside the coffee machine ensure that the coil gets the correct amount of electrical current to keep it at an even temperature. The optimal water temperature for brewing coffee is between 195 to 205 degrees Fahrenheit or 90.6 to 96.1 degrees Celsius. This resistive heating element transfers heat to the water via conduction, allowing the water to boil. Most coffee machines also have a hot plate on which the carafe holding the brewed water sits. This hot plate transfers heat via free convection as the air above the plate is heated. The heat of the hot plate, supplied by electrical current, is transferred to the glass carafe, which then heats the coffee inside via conduction.
The second mechanism of transport we see in the coffee machine is mass transport. This is the diffusion of molecules via concentration gradient. Molecules move in the direction of higher concentration to lower concentration. In a coffee machine, molecules undergo mass transport during the filtration process. When the boiling water passes through the coffee grounds, a leaching process occurs. Leaching is a type of mass transport where a liquid, in this case water, acts as a solvent and comes into contact with a solid, in this case coffee grounds, which acts as a solute. The coffee grounds contain acids, fats, and sugars that are dissolved by the water as it passes through. The higher concentration of these molecules in the grounds travels to the water, where there is a much lower concentration. This process is a form of solid-liquid extraction. The size of the coffee grounds is an important factor to consider. Smaller grounds maximize contact area between the grounds and the water, which facilitates better separation. In addition, the temperature of the water is important as solutes dissolve more in hotter solvents.
The last transport mechanism that we will see in coffee machines is momentum transfer. Momentum is the transfer of a fluid due to a pressure gradient. In the coffee maker, momentum transport is applicable to the transport of water from the reservoir at the bottom of the machine to the filter at the top of the machine where the coffee grounds are located. When the water boils in the reservoir, the water begins to evaporate into a vapor phase. The vapor increases the pressure inside the reservoir, creating a pressure gradient that allows the water to travel up a tube to the faucet, which sprays the water over the coffee grounds. The machine utilizes a bubble pump. A bubble pump is a one-way valve that presents a simple way to passively transport fluids. The bubble pump allows for water to move only from the reservoir to the top of the machine where the filter is located. When the water in the reservoir is heated, the water goes from a one-phase fluid in the liquid state to a two-phase fluid consisting of the liquid and vapor phase. The less dense vapor makes the water become more buoyant, allowing it to travel up the tube to the top of the machine. This buoyancy force results from the vapor bubbles exerting an upward force on the water, which counteracts the downward force of gravity.
Another important factor to consider is the Reynolds number. Reynolds number is a dimensionless parameter that characterizes the flow of a fluid through a tube. It represents the ratio of inertial forces to viscous forces. Reynolds number depends on the velocity of the fluid, the density of the fluid, the diameter of the pipe, and the viscosity of the fluid. A large Reynolds number, greater than 5,000, tells us that the flow is turbulent or characterized by chaotic fluctuation. A Reynolds number that is less than 2300 tells us that the flow is laminar, meaning that the fluid layers slide over each other and interact only at the molecular level. A Reynolds number in between represents a transition flow. As we have explored, there's much more going on inside your coffee machine every morning than you may expect. Next time you make a cup of joe, consider these transport mechanisms that allow you to be caffeinated throughout your day.